Let's take a look at this example. We're supposed to find the following currents and voltages and powers. So from where I want to start? Let's find VA and VB first. VA is the voltage from this point to the ground. Okay, so this is my ground. So if you are going to measure the voltage from this point to ground, you are going to measure the voltage across voltage source 2. So I can say that VA is equal, and because point VA is connected to the negative terminal and the positive terminal is connected to the ground, you are going to measure negative voltage. So I have negative voltage source 2, and this is equal negative 15 volts. VB is the voltage from this point to the ground. So as you can see, this is again voltage across this voltage source, but this time the positive terminal is connected to this point. So this is going to be positive voltage source 1. This is going to be equal 10 volts. So VAB is equal VA minus VB, where VA is equal negative 15 volts minus, of course this is VB, minus 10 volts. This is equal negative 25 volts. So we found VAB. Next, we're supposed to find, let's say, V2. V2 is the voltage across resistor R2, but please notice that this resistor is shorted. Okay, so it means that the current is not going to flow by this resistor. The current will flow around this resistor, okay, because we gave the current option. So keep in mind that current is a very lazy guy, and if has option to go to the ground, right? Go to the ground without any resistance, for sure it's not going to choose the path with the resistance, okay? It's going to always choose the easiest way to reach the ground. That's why this resistor is going to be ignored by the current. That's why V2 is going to be equal 0 volts, okay? Because voltage is equal current times resistance. If there is no current going through the resistor, the voltage is equal 0. Now we can find, let's say, P1. Power at resistor R1. Please notice that this resistor is connected directly to the voltage source 2, right? This voltage source is in parallel with this resistor. So this voltage is across this resistor. So if you want to find P1 is equal V1 square over R1, where V1 is equal, in this case, negative 15 volts to the second power over R1, which is equal to 4 kilo ohms. So this is equal 15 negative to the second power divided by 4 exponent 3 equals 56.25 milliwatts. Okay, so this is my power at resistor R1. Next, I'm supposed to find P3. Keep in mind that this resistor is shorted, okay? So we don't consider this resistor. So this voltage source is in parallel with this resistor. So voltage across this resistor is equal voltage source 1. V3 is equal voltage source 1, and this is equal 10 volts. Right? So if we want to find power at this resistor, we simply use the formula P3 is equal V3 to the second power over R3. Right, so we have 10 volts to the second power over R3, which is equal at 6 kilo ohms. This is equal 10 to the second power divided by 6 exponent 3. This is equal 16.67 milliwatts. Okay, so we found P1 and we found P3. If we want to find the current which goes through the source 2, we're supposed to realize that this is the current which will flow in this loop. Okay, so we can say that I source 2 is equal to I1. This is the same current, okay, because we are going to ignore the very low current which will go by the voltmeter. Okay, please keep in mind that the resistance of the voltmeter is not given, so that's why we are going to ignore it. We are going to assume that this is like an open circuit over here, because resistance of the voltmeter is extremely high comparing with these resistors, so the current is going to appear only in this loop or this loop. But because we are talking about this current, I mean current I1 and I source 2, okay, so they are the same because this is the same current, and this is going to be calculated by Ohm's law. Simply divide voltage source 2 over R1. Voltage source 2 is equal what? 15 volts over R1, 4 kilo ohms. This is equal 15 divided by 4 exponent 3 equals 3.75 milliamps. Okay, and if I want to find I2, we said that the current is going to ignore this resistance. Okay, it is going to go around, okay, because if we give the current option to go by the resistance or go without the resistance, it's going to always choose the option without the resistance. That's why I2 is equal 0 amps. Okay, the current is going to go this way to the ground. It's not going to go by the resistor, because this is like a closed door, this is like an open door. You always choose the open door instead of trying to find the keys to get to the same room by the closed door if the other one is open. Okay, so we found the currents, we found the voltages, and we found the power, so we can say that the problem is solved.